Good morning, ladies and gentlemen. I'm Sarah Bouakkaz, PhD student. Today the topic of my presentation is effects of incorporation rate and the incubation time on the physical stability and the crossing content of saffron yogurt. The aim of this study is to incorporate saffron crossing extract as a natural dye and antioxidant in yogurt in order to obtain an innovative fermented product rich in natural dyes and antioxidants beneficial for health. For that, we fix two objectives. The first objective is to incorporate crossing extract into the yogurt and optimize the condition for its elaboration. The second objective is monitor the physical stability of the enriched yogurt, the crossing content, and also the colorimetric parameters after 7 days of storage. Now we go to the material and the methods part. We start with the extraction of the crossing. For this we need saffron stigma powder, which is diluted in a solvent and it is subjected to stirring, centrifugation and finally filtration, and we get our crossing extract. For the preparation of our yogurts, we need milk, sugar and milk powder, which we heat at 60 degrees for 10 minutes. After cooling to 43 degrees, we add a pot of natural yogurt and we ferment in a yogurt maker. We go to the optimization of our yogurt. For that we have two methods, which are sequential optimization and by design of experiments. We start with the sequential optimization. We will set the pH at 4.6 at different incubation time from 2 hours to 12 hours and different incorporation rate from 6% to 18%. For the second optimization, it is carried out by the composite control plane. For this, we need a GMP software which is used to analyze the experimental data which are then fitted to a polynomial order model, which is described by the following equation. Once our extract is obtained, our yogurt has been enriched with a rate of 6%, 12%, 18%. Then we incubate our product in a yogurt maker for the period between 2 hours and 12 hours, and we stop the fermentation when the pH reaches 4.6. Once our yogurt is prepared, we will follow the physical-chemical parameters, including acidity, viscosity, sinuosis, water retention capacity, which are calculated by these formulas that we see on this slide. In order to determine the crossing content, we need a sample of our enriched yogurt, which is diluted in distillated water, and it is subjected to stirring, centrifugation, and filtration, and then the extract obtained is measured by a spectrophotometer. Finally, the crossing content is calculated by the following formula. Regarding the colorimetric parameters, the images of our samples are taken by digital camera, and these images are analyzed by Adobe Photoshop software. And to calculate the coloring power or multiply the absorbance of our extract by factor of 250, as described in the following formula. To make the statistical analysis, we had recourse to software Statistica and GMP, and of course the calculations were carried out by Excel. We now go to the results and discussion parts. We start with the optimization results by sequential methodology. As you see on this slide, on this graph, which represent the pH as a function of the incubation time. As you know, the pH is always set at 4.6. We see in graph 1, the witness has a duration of 4 hours 34 minutes. In graph 2, we have 6% of extract with a duration of 4 hours 30 minutes. In graph 4, we have 18% of extract with a duration of 4 hours 24 minutes. Note that the best duration is 4 hours 11 minutes, which is represented by graph 3 with a rate of 12% of crossing extract. Deduce that it is better in terms of saving whether energy or financial. Regarding the optimization by response surface methodology, the results show, as indicated by the spatial representation, that the incubation time has a significant and quadratic effect on the preparation of the yogurt, and that the incorporation rate has no effect significant. We also notice that among these two factors, only the incorporation rate has a linear effect on the pH. The result of optimization by these methods, after of course having fixed the pH at 4.6, are 4 hours 5 minutes for duration incubation and 11.9% for the incorporation rate. These values are very close to that obtained by the other methods. Now we will discuss the results of the physico-chemical parameters of the yogurt after 7 days of storage. According to this result displayed in the following table, the acidity increased proportionally with the rate of the incorporation, and we also noticed that the optimized yogurt is less acidic than any other preparation, and also it less viscous than the other preparation. This is probably due to the interaction between the carbohydrates of the crossing and the casein of the yogurt. We notice that the synerlysis of the optimized product is more important compared to the controls, and that is probably due to the higher water content present in the added extract, but it is a technical problem that can be solved in industry, and what explains that the water retention capacity of the optimized product is less important compared to the controls, and that is probably due to the excess of polyphenol present in the added extract. Regarding the result of phytochemical parameters, which is the crossing content, it is observed that the optimized yogurt has a better content, despite the approximation of their incorporation rate. We now go to the colorimetric parameters. The results show that the coloring power gradually increased with the rate of incorporation, which is logical. We also notice that the optimized yogurt has a better coloring power. For this, studies must be carried out in industry to use the crossing of saffron as a natural colorant. As a conclusion, I would say that, according to these results obtained, the stability of the optimized product is mentioned, as well as the coloring power. Therefore, our objectives are achieved, since our enriched yogurt is rich in crossing with a good coloring power in a short time with a reasonable incorporation rate. In perspective, several roles can be played in the continuity of this, in order to expand the use of crossing as a natural dyes in the food industry and put an end of the use of synthetic dyes. Thank you for your attention. I hope you enjoyed it.